Hello, a very good morning to all of you. My name is Abhishek Kirar, and in this video, I am going to uh, explain topics regarding to machine learning. And thank you for giving me opportunity to all the AlmaBetter members. So, in this video, we are going to see some uh, topics regarding machine learning. So here and based on this topic, there are some questions are going to be answered. So now we are going to start this video. So first that in machine learning uh, there are term called ETL and ELT. So we are going to just see the difference between ETL and ELT, and also we will see what are the steps of ETL process. So ETL and ELT are basically the abbreviation of extract, transform, and load, and ELT is abbreviation of extract, load, and transform. So uh, these are the process used to move and process data from multiple sources into a central location, such as a data warehouse or data lake. So the main difference between ETL and ELT is the order in which the data is processed. So in ETL, data is extracted from multiple resources, then transformed to fit the structure to the target system, and then loaded into the target system. So and but in ELT, data is extracted from multiple sources and loaded into a central location, and then transformed to fit the structure to the target system. So now we are going to see the process ELT ETL process. So which typically involves some steps. So first is extraction. So the process of retrieving data from multiple sources such as databases, flat files, or APIs. After the extraction, we will going to transform the data. So the process of cleaning, normalizing, and transforming the data to fit the structure and format to the target system. And this may include tasks such as data validation, data mapping, and data aggregation. After that, uh, the next process is loading. So in this process of loading the transform data into the target system, such as data warehouse or data lake, and then we are going to check the data quality. So in this process, validating and ensuring the data is accurate, complete, and consistent. And after that, the last step of ETL process is data governance. So in this process of uh, maintaining data lineage, security, data privacy, and compliance. So this was a brief about ETL and ELT process. So basically, the difference between in these two processes, in ETL, raw data is extracted from uh, disparate sources, but in ELT, raw data is extracted from disparate sources also. So after that, uh, in ETL, the data is transformed on a secondary server or a staging area. But in ELT process, the data is transformed within the data warehouse or system. And after that, data is in ETL, data is loaded onto the warehouse or system after the transformation. But in ELT, raw data is loaded directly into the warehouse or the system before the transformation. Now we are going to cover that what is Bayes theorem and what is posterior and likelihood. So basically, Bayes theorem is just the probability of A to the B, which is equal to probability of B to the A multiplied by probability of A divided by probability of B. So where P of A to the B is the conditional probability of event A occurring given that event B has already occurred, and this is also known as the posterior probability. and PB of A is the conditional probability of event B occurring given that uh, event A has already been occurred, and this is also known as the likelihood. And P of A is the probability of event A occurring, and P of B is the probability of event B occurring. So, in simple terms, Bayes' theorem states that the probability of an event A occurring given that another event B has already occurred, and it is proportional to the likelihood of event B given A and the prior probability of event A. So the posterior probability is the probability of an event or hypothesis given the evidence available, and likelihood is the probability of a given observation or evidence under a specific hypothesis. And posterior probability is used in many fields like artificial intelligence, machine learning, and statistics to update the probability of a hypothesis given new evidence. But likelihood is used in the same field to evaluate how well a hypothesis explains the given evidence. So now we are going to see that what is dimensionality reduction, and what is the difference between LD and PCA. So dimensionality reduction is a technique used in machine learning. So when the number of features in a data set is very large in the number to overcome these curves, we use PCA and LDA like algorithm to overcome this problem. And also we have to maintain as much of the important information as possible. So basically PSA is the abbreviation of principal component analysis. So it is the technique that finds the linear combination of the original features that capture most variance in data, and it is an unsupervised technique, and it aims to find the direction of maximum variance in the data. But if we see the LDA, so LDA is the abbreviation of discriminants analysis. So it is a supervised technique that finds the linear combination of the original features that best separate different classes. So it tries to find the direction that maximize the separation between different classes while minimizing the variance within each class. So this is all about the dimensional reduction. Now we are going to see that what is the difference between sample and population, and what is sample size, and also we are going to see the types of sampling techniques. So population is basically an entire group of individuals or objects or data which researchers want to uh, study on. On the other hand, a sample is a small subset of population which represents the population. So sample size is basically refers to the number of individual or data present in a sample. So it is an important consideration in statistical analysis, because the larger the sample size, generally sample must be greater than 30 will be considered valid sample. So there are different types of sampling technique which include simple random sampling. So a method where every member of population has an equal chance of being selected over the sample for the sample. And the next technique is stratified random sampling. So in this method where the population is divided into subgroups, or or a simple random sample is selected from each stratum. Now the third technique is called as cluster sampling. So in this method where the population is divided into groups and a random sample of cluster is selected. Now the next technique is systematic sampling. So it is the method where the population is ordered and then every nth member is selected for the sample. Now the next technique is known as convenience sampling. So in this method where the sample is selected based on the ease of access to the individuals or objects in the population. And the last technique is called as snowball sampling. So in this method, where initial subjects recruit others from the target population and so on. So now we are going to see that what is the difference between TF-IDF and word to vector, or can say word to vec. So basically TF-IDF is the abbreviation of term frequency inverse document frequency. So it is a technique used for converting text into numeric form with having some emphasis on emphasis on criteria criterion important words by considering both the frequency of the word in the document and how rare the word is across all document, and it is to used as an input for feeding the model. But on the other hand, word to vec is represents word in a high dimensional vector space where each dimension corresponds to a feature of the word, and it captures the meaning of the words based on the context in which they appear. So now we will see that how we can explain a machine learning to an MBA student. So in general term, we can explain in a way that it is a part of artificial intelligence, or we can say uh, it is a way for computers to automatically improve their performance on a task by learning from the data. And this includes various stats model, which is basically called algorithm. So by using these algorithm on existing data generated by people, we can took or predict some useful insights, which can be really helpful in business growth. So for example, we can say a retail store wants to optimize its pricing strategy by determining the optimal price for each product. So a machine learning algorithm can be used to analyze historical sales data and identify patterns between the product price uh, and the demand. And so the algorithm would then use that information to make prediction about what the optimal price for each product should be in the future. So this is a brief about the machine learning algorithms we can explain to an MBA student. So now we will see that what is the difference between a grid search and random search. So basically, these both techniques are used for hyperparameter optimization, and or we can say that it is these techniques are used for optimizing and reducing overfitting the model. So in grid search, CV uh, it conduct on a predefined set of hyperparameters. So the model evaluates the performance of the each combination of hyperparameters in the grid and return the combination that performs the best. So this method is simple and easy to implement, but it can be computationally expensive and time consuming. So because if the grid is large, so but in the random search, it randomly it randomly samples hyperparameters from a predefined distribution for a fixed number of iterations. So the algorithm evaluates the model performance for each set of sampled hyperparameters and returns the combination that performs the best. So this method is more computationally efficient than grid search, but it may not find the best combination of hyperparameter. So if the search space is large or the number of iteration is small, but in terms of time complexity, it is very efficient to use. Now we will see that what is some central limit theorem and what general condition must be satisfied for the central limit theorem to hold. So basically, central limit theorem says that if we are taking subsamples from population and calculate the mean for every sample, and after average sum of the subsamples is approximately equal to the population mean, and the distribution of these mean is always be normal, or we can say it will, if we draw this mean on the graph, then it will always be in the bell shaped curve, or evenly distributed. So for central limit theorem to hold, there are following general conditions must be met. So the sample size must be greater than 30 or equal to 30, and also uh, samples must be independently and identically distributed, random samples, and the underlying distribution of the population must be finite variance, and the sample size should be large enough to consider the sample mean to be approximately normally distributed. So, so this is a brief idea about central limit theorem. So now we are moving to that what is n-gram language model, and what is the difference between unigram, bigram, and trigram in natural language processing or NLP, and how do n-gram language model works, how, and we will also mention its application. So basically, an n-gram language model is a type of statistical model that uses a sequence of n words to predict the next word in a sentence or text. So n-gram can be unigram, bigram, or trigram. Or unigram means one word, bigram means two words, trigram means three words, or higher order n-gram. So n-gram basically n words. So unigram model is a language where the probability of each word is computed independently of the others. That is, it does not take into account the context of the word. And bigram models consider the probability of the each word in a sentence given the previous word and so on. And in trigrams models, consider the probability of each word given the previous two words. So in n-gram language model, the probability of a word is calculated based on the probability of the previous n1 words. So the model is trained on a large corpus of text, and the probability of each word is calculated based on the frequency of that word, and its preceding n minus 1 word is also a training corpus. So n-gram language models are commonly used in natural language processing, or we can say NLP. So such as the speech recognition, translation, and text reduction and generation. So they are also used in information retrieval and information extraction to improve the accuracy of search result and text classification. So now we are moving towards the executing a binary classification tree algorithm in a simple task, and how does tree splitting takes place, and also how does the tree determine which variable to break at the root node and which at its child nodes. So basically binary classification determines which variable to break at root node on the basis of information gain and gene impurity. So information gain is entropy is uncertain, or we can say randomness in the data. So the more the randomness, the higher will be the entropy. And information gain uses entropy to make decisions. So if the entropy is less, information will be more. Or information gain is used in decision trees and random forest to decide the best split. And if we talk about the Gini impurity, so Gini impurity is a measurement used to build decision trees to determine how the features of a dataset should splits node to uh, form the tree. So now we are moving to what are the different types of gradient descent algorithm, and or we are also going to differentiate between these gradient descent algorithms. So gradient descent is a an optimization algorithm used to minimize the error of a machine learning model by adjusting the parameters of the model. So different gradient descent, there are different gradient descent algorithms. The first is gradient descent. The second is stochastic gradient descent, and the other one is mini batch gradient descent algorithm, and the another one is momentum, as or we can say stochastic gradient descent with momentum, and the last one is adaptive gradient descent. So batch gradient descent uses the entire data set to calculate the gradient descent of the cost function at which at each iteration, and it is computationally expensive as it requires a lot of memory to store the training data, but it is also the most accurate as it uses all the data to update the model. Now the next is stochastic gradient descent. So it is basically uses a single training example to calculate the gradient of the cost function at each iteration. It is computationally efficient as it requires less memory, but it is also less accurate as it uses only a small sample of the data to update the model. And now the third one is mini batch gradient descent. So it is basically the variation of stochastic gradient descent, where a small subset of the training data is used to calculate the gradient at each iteration. It is trade-off between batch and stochastic gradient descent, as it uses a small sample of the data to update the model, but it is more accurate than SGD. Now we are moving to what is activation function in neural network, and what are the different types of it, and also what is the difference between sigmoid, uh, rectified linear units, and softmax activation function, and which one is better. So basically activation function is a mathematical equation applied to output of a neuron to decide whether it should be activated or not. So basically activation functions introduce non-linearity into the neural network and allowing it to learn complex relationship between inputs and outputs. So sigmoid, it is a smooth S-shaped function that maps any input value to a value between 0 to 1. Now the next one is rectified linear unit. So it is a sample function that maps any input value less than 0 to 1, and any input value greater than or equal to 0 to input value. And the another one is softmax. So it is a function that maps a vector of real number to a probability distribution. So it is commonly used as the activation function for the output layer of a neural network for classification. So basically we can say that it depends on the location of activation, where it is placed, and architecture of a neural network and how it is built. So sigmoid and softmax is used for binary and multi-class classification at the output layer, where rectified linear unit is mostly used in hidden layers of a neural network, and it is computationally efficient, and it helps in avoiding the vanishing gradient problem. Now we are moving to what is the difference between collaborating and content based recommendation system. So basically recommendation systems are algorithm which is used for predicting the user preferences, or we can say rating a user would give a certain item. So there are two types of recommendation system algorithms. So first is collaborative. So uh, it is a filtering method of making recommendation by identifying the other user who share similar preferences or ratings, and making recommendation based on what those similar users have liked. So collaborative filtering can be further classified into two categories: memory based and model based. So memory based system look at the past behavior of users and items to identify patterns, while model-based system are use algorithm like matrix factorization to build a model of user preference. And the next is content-based filtering. So it is uh, it is a method of making recommendation by identifying the characteristics of items that a user likes and recommending similar items. So in content-based filtering, systems use the attributes of items such as genre, director, actors, etc. to recommend similar items. And this method is often used when there is no explicit feedback data or on user preferences, and it relies on the characteristics of the item. So now we will see what is Selot score and what is probability simplex. So Selot score is defines the similarity between an object and objects in cluster. So and it ranges between -1 to 1, where a value close to -1 indicate dissimilarity with cluster, that is it belongs to another cluster, and value close to 1 indicate the well match to its own cluster. So in the probability simplex, it is a mathematical concept that refer to the space of probability distribution over a given set of items. So it's often used in statistics, machine learning, and the other field of mathematics. Simplex is a convex set that contains all possible probability distribution over a set of items. So in other words, it's a set of all possible web points in space that represent different probability distribution over a set of items. So this is all about the lot score and probability simplex. Now we are moving and going to see that what is the difference between covariance and correlation, and what are its range and domain for both. So covariance is a measure of the relationship between two variables. So it tells us how much two variables change together, and a positive covariance means that the variable increases or decreases together, while a negative covariance means mm, that one variable increases as the other decreases. So the range of the covariance is minus infinity to plus infinity, and the domain is real numbers. Now if we talk about the correlation, so it is a standardized measure to of the strength and the direction of the linear relationship between two variables. So correlation ranges from -1 to 1. So with -1 indicating a perfect negative correlation, and 0 indicating that there is no correlation between the variables, and the 1 indicating a perfect positive correlation. So the range of correlation from -1 to 1, and the domain is real number. So this is all about today's video. So we have covered few topics regarding machine learning. Hope uh, they are a bit clear to all of you who are seeing this video, watching this video. So thank you so much, and thank you AlmaBetter for this opportunity.